Did you ever wonder as a kid if we eventually colonize the moon? Could we just run a giant pipe from Earth's oceans all the way to the lunar surface? It sounds like the ultimate low-energy solution. Think about it. When you drink through a straw, you're just lowering the air pressure in your mouth, and Earth's atmosphere does the heavy lifting by pushing the liquid up. Since the moon is a near-perfect vacuum, you'd think that massive pressure difference would create an endless, self-sustaining fountain. But physics has a brutal reality check. Earth's atmosphere is only dense enough to push water up to a height of about 10 meters. Even if we swapped our air for the crushing atmosphere of Venus, that water column would still only reach 900 meters, nowhere near the 384,000 kilometers required to reach our lunar neighbor. So, you decide to get serious and install a massive mechanical pump on the Earth's end. But here is where things get truly dangerous. A water column of that staggering length would exert a pressure of over 3 billion megapascals at the base. Under this crushing weight, hydrogen nuclei would overcome their natural repulsion and begin to fuse into helium. Your water pipe would instantly transform into a continuous nuclear fusion reactor, releasing enough energy to vaporize the entire project in a heartbeat. However, there's a fascinating loophole. Because the Earth rotates, centrifugal force actually overcomes gravity once you pass the geostationary line, about 35,000 kilometers up. Beyond this point, water wouldn't press down. It would actually want to fly out toward the moon. To contain this, you'd need a pipe made of graphene, the only material known to science with the required tensile strength. But even then, the water wouldn't flow. At these extreme pressures, water molecules break apart into a state called superionic ice. It becomes a pitch-black, metallic solid that conducts electricity like a wire. The plumbing project is officially dead. But don't worry about the future lunar colonists. They don't need our straw. In the permanent shadows of the moon's poles, ice has survived for billions of years. Water is actually abundant in the cosmos. Jupiter's moon, Europa, hides an ocean 9 times larger than all of Earth's combined. And 12 billion light-years away, a massive quasar holds a reservoir 140 trillion times the size of our oceans. If humanity ever leaves this solar system, we will never truly go thirsty. Yet as we look at those distant stars, we realize that Earth's water is unique. The molecules in deep space never carried the sails of explorers across the horizon. Every single drop on our planet is the collective legacy of the trilobites and the dinosaurs. It is a climatic memory carved over eons by the Antarctic glaciers. When we speak of protecting our water, we aren't just talking about a chemical element. We are preserving our home and our heritage. We do it so that when future explorers look back at that tiny blue dot from the edge of the galaxy, they can still feel that the place they came from is home.